Welcome back, folks. We're still looking at using the output of nodal analysis, the node voltages, the non-reference node voltages, to find other values in the circuit. So I have a similar setup, but now we're finding currents. And currents are a little trickier, not too much trickier. You'll do fine. We would like to be able to do this. I want you to realize that once you know the node voltages, you can find any other value in the circuit. And that's what's really nice about some of these methods of analysis. Mesh analysis, if you know the mesh currents, you can find any other value in the circuit. If you know the node voltages, you can find any other value in the circuit. It's pretty stinking useful. Okay, same kind of game. Here's a circuit. This one's kind of mystical. We don't know what these components are. We're going to pretend they're all passive components. There would be no current flowing if they actually were all passive components. But I think it's a useful exercise in order to say, okay, how do I get from the node voltages to the labeled currents? Okay, and once again, we're going to use passive sign convention. All right, so let's get going with this. And we've got IA. Let's start with IA. And if IA is passing through this resistor in that direction, we've got to think about the polarity. And the positive current is going to enter the positive terminal. So, terminal, I think I said that right. As it's flowing up, right, it's going to enter this terminal. So, positive current enters the positive terminal. So, my polarity is going to look like that for the voltage that's going to be created by the current flowing through the resistance. And we're going to use that voltage because we've got to relate our non-reference node voltages, even our reference node voltage, honestly, to the current. And we're going to do that with Ohm's law, similar to how we did it with mesh analysis, just backwards. And you're going to find that's the case with nodal analysis versus mesh analysis a lot. There's a lot of overlap, but we're just kind of swapping things around. But the approach is generally the same. Okay, so if I'm looking here, I can write that voltage. Right? We can say VR1, okay, VR1 is equal to 0 minus VA. So that's the voltage. If I want to find the current, okay, this is IA, I can take the voltage across that resistor and divide by the resistance, and I have volts over ohms, and that's going to give me amps. Right? All that's left here is to substitute this in, and the 0, of course, is going to drop out. So I can say IA is equal to negative VA over R1. Not too bad. Here's the quick way I do it. And the thing that I say over and over again, and you're going to hear me say it in the coming videos over and over again. I take the, first off, we need to have a lesson on arrows, apparently. There's always somebody in the class that doesn't really know what an arrow is, what the tip of an arrow is, and what the tail of an arrow is. So let's just make sure that that's not an issue for us. Okay, so this is the tip of the arrow, right? That's the point that, like, if you've ever shot a bow and arrow, I don't know if you have or not. That's the tip of the arrow, and I even drew the little feathers on the back end there, and I call that the tail of the arrow. Somebody once corrected me in class. I can't even remember who it was, but they said, well, actually it's called the fletching. I don't know. I'm not a big bow and arrow archery enthusiast. It's called the fletching. I'm going to say tip, and I'm going to say tail. So I'm looking at the arrow for IA going up. And I'm going to say, what's the voltage at the tail of the arrow? Okay, so what's the voltage at the tail of the arrow minus the voltage at the tip of the arrow for the current. And that's going to be over whatever the resistance is. Okay, once again, we get a voltage over a resistance. It's going to give us a current. So I will say that over and over again. So if I look at the voltage at the tail of the arrow, it's 0. I subtract the voltage at the tip of the arrow, and then I divide by the resistance, and that gives me the current. And we can do this on every single one of these, okay? Keeping in mind that ground is 0, so sometimes it drops out, which is nice. But if you want to get the sign right, this is a good way to do it. All right, so let's play this game with IB. Okay, so it's moving left to right, so passive sign convention tells me it's going to be like that, right? That's the voltage at the tail minus the voltage at the tip, and it's going to be over the resistance. So I can come down to IB, and I can say IB is equal to VA minus VB over R2. Simple as that. And that's our current. It's a combination of a KVL to get the voltage across it and Ohm's law to turn it into a current. So it's still working on those fundamental laws. What do we get for IA? We had the voltage at the tail minus the voltage at the tip over the resistance. Got to cram these in a little tighter. I should space those out more. Tough luck. Next time I record all of these videos, I'll do that. Okay, looking at IC. Is that still on the screen? Nope. Okay, looking at IC. The voltage at the tail is VC. The voltage at the tip is VB. And that's over R5. R5. R3. Let's try R3. Good job, Dave. Where's R4? Where's ID? ID is over here. Okay, so the voltage at the tail of ID is VC minus the voltage at the tip. Hey, that's just 0. That's great. And that's over R4. So a lot of textbooks just kind of gloss over that, and they're like, well, it's connected to directly to ground, so it's only going to look like this, VC over R4. And I think that was the first way I was taught, and it took me a little while to go, wait, it's because the other side's ground and it doesn't show up. So it's consistent. If you do things consistently, you're going to get the right answer consistently as well. And that's our goal, is consistently right answers. All right, IE, it's going down. Voltage at the tail is VB minus voltage at the tip is ground. And there's R5. Okay, so again, that would more commonly just be written as VB over R5. I'll continue with this until I hope it sticks in your head. And then as we get more experience with this stuff, I'll move over and I'll just start writing it as a single term in the numerator, because that's a little more typical for what you're going to see in textbooks. IF, how much you want to bet that's all the way on the top? There we go. IF, okay, so we're going left to right, so it's going to be VA minus VC over R6. Okay, so VA minus VC over R6. Not too bad. Hopefully you're feeling okay with this. We're going to use it a lot, and because we're going to use it a lot, I hope you get good at it. Okay, I'm going to pause, so I'm going to jump around a little bit, because I want to get the next piece of this. I'm just flipping around some of the arrows, and really all I want you to see is that if you flip the arrow, the terms in the numerator swap places. That's the only change. But let me grab that for you. Okay, I think the screen probably jumped too. I wasn't paying attention there. But same made-up magical circuit that has no power source in it. But still a useful exercise. Okay, so did I flip every single one? I don't know if I flipped every single one. I flipped IA, that's for sure. IC still goes in. Sorry, I probably should have checked this before. Now you just get to watch me scroll. All I flipped was IA. All I flipped was IA. And we can flip a couple other ones. Okay, so if I'm looking at IA and it's flowing in the opposite direction, the voltage at the tail now is VA. The voltage at the tip is 0, and that's going to be over R1. So that's going to be more typically written as VA over R1. I lost that negative sign. So, well, of course I did, because I changed the coordinate system. It was facing that way, now it's facing that way, and I can indicate that with a negative sign. And we can see that if we kind of follow the procedure, the voltage at the tail minus the voltage at the tip over the resistance, we can not screw up. We get the negative sign correct in the top one, and we can see that we end up without a negative sign down here. So we're good to go. Let's do IB through the magic of on-the-fly editing. We can say, well, actually, IB And it can be labeled on either side. It's the direction of the arrow that's important, right? That's an arrow, believe it or not. Okay, and let's call that IB. Now it's facing to the, it's my left. I hope it's your left too. Now it's facing to the left. The voltage at the tail, in this case, is VB. The voltage at the tip is VA, and that's over R2. Okay, so VB minus VA over R2. While I switch the direction, VA becomes negative, VB becomes positive, and we can see that's the opposite of what we had up here. So we're going to get the opposite sign. The signs are important. Keeping track of them is important, just like it was in mesh analysis. So we got to get this right. So I hope that these last two videos have given you the kind of basic techniques that I use, the things that go through my head when I'm writing these equations for getting the signs correct. Okay, now we got to go get the node voltages. I'm excited. I hope you're excited. Let's go do it. Stay tuned and good luck.